Okay, you guys, so the sheet that says Osmosis Challenge Part 2, this is going to be Part 2 of our lab, a continuation of looking at osmosis, but this time we're going to look at osmosis in living cells. So the cells that we're going to use are potatoes. And so, with this, it says you're not going to apply this to living tissue, this meaning the information that you did, we went over yesterday in the Osmosis Challenge and in the first lab. The tissue is composed of cells. So a tissue is a bunch of cells that perform the same function, that work together. And so we're going to look at a mass of tissue of a potato. And then what we're going to do today is design an experiment to determine the molarity of plant cells. So, using our knowledge based upon what we've done already. So if you look at this sheet here where it says the following materials are available to you. So I'm telling you what you have available to you to design your experiment to figure out what the molarity of the potato cells are. So notice there it says beakers. Actually, I'm going to, instead of using beakers, I decided I have a bunch of plastic cups here. We're going to use cups instead of beakers. You're going to have distilled water at your disposal, and then you're going to have different molar concentrations of sucrose, so 0.2 through 1.0 molar sucrose solutions. Beakers is on there twice. I meant, if you cross out that second beakers, it's a graduated cylinder is what you need to put there. That was what I meant to put there. See how beakers are on the list twice? All right, so you have graduated cylinders, you'll have balances, the same two that we used for our previous lab. You have potatoes, they're just normal, everyday Idaho potatoes here. And so those are the potatoes we're going to be using. And then there's something called a cork borer. And let me show you what a cork borer looks like. All right, so this is a cork borer. If I take this out here, it's a hollow cylinder with a handle on it. What this is going to do is allow us to get uniform pieces of potato. So if you're a potato, each group will have a potato, and what we're going to do, I'll have knives available tomorrow. You're going to cut a piece of the potato out, so cut a slice of the potato out. So then what you'll have is a cylinder of potato where the skin will be on this, around this side, but the top and the bottom will not have the skin on it. So then what we can do is take this cork borer and put your potato on the desk and take the cork borer and push it into the potato till it hits the desk and take it out. And what you'll have is a cylinder of potato in there. So then to get that out, that's what this little guy is for. You can push it in and it'll push out this little cylinder of potato. This will be so that you have uniform pieces and sizes of potato, so that will not be a variable in your experiment. And so you'll have these little cylinders of potato, and they won't have the skin on it. So therefore, the cells inside are exposed, all right, to the environment. So that's what a cork borer is. And then we'll have massing cups available. That's these little guys here, because you're going to mass potatoes. And so instead of putting it on the scale itself, you'll use these massing cups. Okay? So those are your things that you'll have available to you. So as I said, the question is, what's the molarity of the potato cells? So what I'm going to have you do today for about 20 minutes or so is you're going to design an experiment using this materials, using these sucrose solutions and these materials, design an experiment that will help you to figure out what the molarity of the potato is. And then as you work, you have to have me approve it. So what I'll do is you need to write it down and write down what your thoughts are in your group, and write down what you think you're going to do. When you think you have it, call me over, I'll look it over, I'll make suggestions and things like that to you, so that by the time the 20 minutes and by the time you leave today, you're going to have a procedure that you're ready to do, and we're actually going to perform the procedure tomorrow, okay? So that's what you're going to do. All right, so right now I'm going to have you get in your lab groups and go ahead and talk amongst yourselves and come up with a procedure. All right, so if you look at the one that says dilution from a stock solution. So I'm going to do a quick little thing from chemistry. Keep sound coming empty sheet here. So do you guys remember this equation C1 V1 equals C2 V2? Sometimes it's CI VI initial. No. All right. Well, luckily for you, it's not that hard. All right. So let's look at this. We're going to apply this to our lab, and I'll explain how that works. So in just a second. So it says to make a dilution of a stock solution. So you're diluting it with water, making it less strong. All right. So to make a dilution of a stock solution of a known concentration, you use the formula C1V1 equals C2V2, where C1 is the initial concentration, so C stands for concentration. C2 is the final concentration. V1 is the initial volume, so V is volume, and V2 is the final volume. So they give you an example. It says if you dilute 174 milliliters of a 1.6 molar solution of lithium chloride to 1 liter, what's the new concentration of the solution? So what we do is we look at this. We're diluting 174 milliliters of a 1.6 molar concentration. This is a volume, and this is a concentration, the molarity. So this is our original, because we're going to dilute it. So this is what we have originally. So these are the V1 and the C1. All right? Then we're going to dilute it to, it says 1 liter. And so 1 liter is that's a volume, and that's what we're going to end up at the end. So that's our V2. So then I asked you, what's the new concentration of the solution? So what is our concentration at the end? So concentration is C, at the end is the C2. So that's what we do, and that's what they did here. In our lab, we're going to be working with milliliters and not liters. And so we're going to I'm going to have you keep your units to milliliters. So if you look here, they put and assigned what we just did together here, right here. Notice that our V1 and our V2, they've given it in two different measurements, milliliters and liters. There are 1,000 milliliters in 1 liter. So we're going to use the unit milliliters. So I'm going to put here, this is 1,000 milliliters. We're going to change this here and cross this out because they used it liters, but I want to keep it consistent with what we're doing in the lab. All right, and so then what they do is we're solving for C2. That's the one where we want to know what it is. So they take that equation and manipulate it so that you're solving for C2. So you divide by V2 both sides, and so this is our equation. We plug in our numbers, so 1.6 molar, and then I'm going to change this, oh no, not that, I'm going to change this to 1,000 milliliters. All right, and leave that, don't cross that off on yours. And so then you multiply this all out, all right? Oh, they changed it. Oh, yeah, you should cross that out. I forgot. We need to change that to milliliters here. We're keeping it milliliters. We're saying milliliters and milliliters here. All right? So then our units of milliliters cross out, and we're left with molar. So if you can multiply 1.6 times 174 and divide it by 1, instead, so this was with liters, so this is going to be what is it going to be? Actually, multiply that out and tell me what it's going to be. I'm going to do it with liters, milliliters. Multiply that out. You're going to need the calculator for the next 2 problems, so you might as well get your calculator out. Should be it. I want to show you that using liters or milliliters, you get the same, as long as you're using the same units, you will get the same thing. All right, so they use liters, we use milliliters, but we get the same answer there. So I want us to always use milliliters, because that's what we're going to do in the lab. So whenever they give you a liter, we're going to change it to milliliters. So everybody try this first problem here. So kind of do what I did. See if you can assign what each value is, and see if you can do that. if we look at this, the stock solution is 1 molar. So your stock solution, that's usually what you start out with, and that's concentration, so that's your C1. All right, then you diluted it and made, so these are going to be your final values. You made 250 milliliters, that's a volume, so that's what you made, and so that's your V2. And 0.5, that's your concentration, and so that is C2. Then it asked you what was the volume of the stock solution, so that was what you originally had. So we're solving for V1. So if we manipulate the equation, this is what our equation looks like then. V1 equals C2 V2 divided by C1. So C2 is 0.5 molar. V2 is 250 milliliters. We're going to use milliliters, so that's good. It's already in that format. Divided by C1, which is 1 molar. The molar units cancel out. We're left with the milliliter units. And so when you do that, you get 125 milliliters. All right? All right, so that's what V1 equals. Okay? So, let's try that second problem, just to make sure that you get it, and then I'll talk about how it applies to our lab. All right, so if you haven't done that second problem, do it now. Some people I think already done. Oh, it's 1 molar, I think. Alright, so by diluting a stock solution, you made 2 liters. So this is what you made. This is your volume 2, V2, 2 liters of a 0.2 molar solution. That's your concentration, and that was your final concentration, so that's C2. Your stock solution is a volume of, that is V1, and it's asking you what your original concentration was, so you're solving for C1. So in looking at here then, C1 is going to equal C2 V2 divided by V1, right? And so when we looked at this, then you take C2, which was 0.2 molar, V2, which was 2 liters, but what would we change that to? 2,000 milliliters, if we want to use the milliliter unit, divided by V1, which is 500 milliliters. And so milliliters will cancel out, so we'll end up with molarity because we're solving for concentration, and you should get 0.8 molar. All right? And so that's how that works. Now let's talk about how this relates to our lab. All right? So tomorrow, you are going to get, I'm going to give you 350 milliliters of a 1 molar sucrose solution. Your job is going to use this stock, this is going to be your stock solution. You are going to use this solution to make the 0.2, 0.4, 0.6, and 0.8 molar solutions. So how are you going to do that? All right, so what you need to do is you're going to make 100 milliliters of a 0.2 molar, 0.4 molar, 0.6 molar, 0.8 molar, and then the 1 molar you don't have to make because you'll already have 100 milliliters left over from your stock solution. So we are going to make 100 milliliters of each one of these. So how are you going to do that? So what we're really doing, so if I look at how to do a 0.2, we want 100 milliliters of a 0.2 molar solution from our stock solution from a 1 molar sucrose solution. This is our problem. So we have to dilute this 1 molar solution to make a 0.2 molar. So what I want to do is figure out how much of this stock solution do we need to dilute. So what this is what you want. This is your final. So this is your V2, and this is your C2. This is what we want at the end. This, the 1 molar sucrose, is C1, correct? what we want to do is figure out what the volume, how much of this do we need to dilute. So we're going to solve for B2. So if we solve for B2, sorry, B1. Sorry, I was looking at B2 here. B1, we want to know how much of the stock solution to use. So B1 equals C2V2 over C1. So we are going to use and get our C2 is 0.2 molar. Our V2 is 100 milliliters. C1 is 1 molar. So this is what our thing looks like. Molar concentration, the molar units cancel out. We're left with milliliters. 0.2 times 100 gives us how many milliliters? 20 milliliters. So this is, we are going to need then, out of this 350, 20 milliliters of the stock solution. So what does this mean? You want, in your cup, you're going to use, you want 100 milliliters of a 0.2 molar solution. So what you're going to do is you're going to take 20 milliliters of that stock solution, which is the 1 molar solution. You need 20 of that. And then you're going to dilute it up to 100. So you're going to dilute it then with distilled water. So you're going to need 80 milliliters of distilled water, and that makes a 0.2 molar solution. Does that make sense? All right. And so then you'll do the same thing with the 0.4, 0.6, and so on. All right? All right? So, stuck it in just a bit. Sure. You guys, I'm going to change, real quickly, you guys, I'm going to change the water potential problems due on Friday. All right? All right? So change it today.
What are those?
Those are the things that you picked up 2 days ago. It says AP water potential problems at the top.